every time you flush a toilet in Connecticut, a little bit of fentanyl might end up in an oyster. And that oyster? It's not handling it well. Oysters are nature's water filters. A single adult can clean 50 gallons of water per day. They're also the backbone of a $9 billion coastal economy in Long Island Sound. But they start life as microscopic larvae, tiny swimmers that have to find a shell to attach to, or they die. Scientists at UMass Lowell wanted to know what happens when those larvae swim through water laced with the same drugs flowing out of our cities. They tested 3 substances: fentanyl, ketamine, and benzoylecgonine. That's the compound your body makes after you use cocaine. All 3 show up in coastal waters because wastewater treatment plants can't fully remove them, and global drug consumption is rising. The researchers exposed 3-day-old oyster larvae to drug concentrations matching what's actually in the environment, not exaggerated lab conditions, real-world levels. After 2 weeks, survival dropped across the board. The cocaine byproduct hit hardest. Up to 76% of those larvae died compared to the control group. But it wasn't just about dying. The survivors were different. Larvae exposed to ketamine slowed down dramatically. Most stopped moving entirely. And fentanyl? It changed their swimming pattern from straight lines to circles, like they were lost, disoriented. When oyster larvae can't swim properly, they can't find shells to attach to. And if they can't attach, they become food for everything else in the water. They never become the 50-gallon-a-day filters that keep the ecosystem healthy. Here's what caught the researchers off guard. They expected this at high concentrations. But these were trace amounts, the background hum of human consumption flowing into the sea. At the molecular level, stress genes in these larvae spiked 7-fold after just 4 hours of exposure. This isn't about oysters getting high. It's about an entire species showing signs of chronic low-level poisoning from drugs that never fully leave the water cycle. Connecticut is spending millions trying to restore oyster populations. Meanwhile, every flush carries a chemical signature of everything we consume. The question isn't whether drugs are in the water. It's whether we're going to do anything about it before the filters stop working.